Okay, so this will be me solving the highlight of the shoot forward minimum of platforms required for railway. Let's choose practice. And then this platforms, question mark. Given the audience is people in the arrival and the class at time of trains stop at the platform. They need to find the minimum platform seated at the railway station so that no train has to wait. Right, so given an average, we start at time of train find the minimum level platform for trains to the platform and stop to the same time for train has the department for passenger data. So sometimes it's 900 to 900 ton. Hmm. Okay, so what is the beauty factor? Factor. How do we separate it? Hmm. Let's start a timer. Okay, the train starts at 900 and it is at 910, it is at 940, 200. Hmm. 900 to 910 falls in the same zone, 940 to 2 so there's a difference, 950 to 400. Hmm. Okay, if they don't clash, they won't exit, but if they clash, we increase the counter. How about that? How do we check to know? Okay, suppose this is the minimum value. Okay, first we sort on the basis of arrival of the train. Suppose it's the sort on the basis of arrival of the train. So if it's a pair of INT somehow it will be the answer. And for and the category I will first and answer that. Oh, assuming to the answer editor. I now sort of I so and now this sorting answer of beginning and answer that and that helps to get sorted. So let me see how the answer is. So, I will answer here. Maybe that first, maybe that second. Let me see. Okay, so 919 falls in the same zone, 940 to 1200. Now 940 to 1100 just falls under the same zone. Will increase account. Ah, so 919 false course. So suppose if we have something called count, which will be returned. Now, if IT dot first, this is IT dot first, this is IT dot second. Suppose the IT of first is greater than this value. Hmm. How do we make a limit? Okay. And say start with equals to 0 and equal 0. Now, basically, since it's sorted in the starting line, okay, trains are coming. Trains are coming in every iteration, trains are coming. So at every iteration, trains are coming. And the moment you, oh yeah, so suppose the left, mm, so last left train value is 0. But what if not so? So suppose 9 meters and last leaving time, last train, hmm. And then 9:40 train arrives, so it is fine. But if it clashes, 1200, and if it clashes, the count increases, 700 clashes, count increases, 1511 clashes, 1800 clashes. Hmm. Hmm. I don't think it will work, but let's try. So this is this, and last left of train is equal to, and so last left train, comma, period second. I wrote first is greater than last left train. That is fine. Else, what we do is that local count is 0. What we do is local count is increased. That seems to be wrong. We sort by the order that train leaves. We local count will increase and count is equal to max of comma local count. And at the moment that no, the next expression of count will become 0. Okay, so what do we do is the local count becomes 0, and then you stop the iteration. Oh, you don't stop the iteration. That's how to say it. Okay, right now the answer is 2 because of starts with uh, probably. I mean, yeah, we always need a one single patch, but no, the answer is still 2. So it's spent the moment that according to it, the moment 9:50 train arrives and 11 train arrives. If a 9:50 train arrives, count should become 2. 1100 train arrives, count should become 3. Mm, oh, this one should become okay, sorry. I don't think this will be right. Oh, yes. So, hmm, okay, just um, hmm, Let's see how the spot one looks. Is to 4 to 2, 3, 2, 3, 357. Train wise, to 8, train is there, 825, 1120. I'm not sure. So, it should be another key to this. Hmm. 11.9 minutes. Minutes. 54 to 323, 7 to 58, 825, 1120, 110, and 14. Hmm. Hmm. Okay, let us take a small hint if that helps. So minimum platform, the question is minimum number of platforms required for delivery. Uh, so give me a very small kind of minimum number of platforms for delivery. Okay, don't think about things, think about the events happening on the station line, like what changes from the platforms, obviously that in China. Very good, this is what I have thought. Nothing good. Okay, so after sorting whatever time I was is remembering the last past couple of obviously not. So my multiple times on time in the body well and at least it is the last name. Really was working. So I really have to find this. So I really go to match. Let's see, the earliest departure now. What? Okay, so basically think about which lets you know the earliest departure among all that. Okay, so basically suppose multiple trains are coming. How do you know the train which is only leaving the? So what is sort of question? This one, we push this one, and then this one. So the uh, yeah. So this was leaving this time. Hmm. How do you say? Okay. Return 950. This is our last earliest leaving time. So 900 is the time when the train came and 10 left. 9:50, 11:28 left. 1100 not train came. Came before this train left. So one more track needs to be added. Now 11:30 the train leaves. 9:40 the train. How do we know the time? Hmm. How do we do this? What is the greedy approach? Okay, I have no idea.
Hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is minimum number of platforms required for a railway station. So what is the problem statement? You have arrives and that each of these end trains can I just need one. So can I say that a platform 20? Okay. Let's check platform number 2. Platform will be empty. So what? Take the platform number 1. Perfect. Let's check the next one out. The next one is going to arrive at 9:55. So if it is arriving at 9:55, can it arrive at 9:45 to 12:02? And no, can it go? So arrive at what? So will it platform at max if you have 3 platforms, you can able to accommodate 3 platforms will be enough because so what will be the brute force? Like what is the brute force? Again, I did say a word, intersecting, right? Because the arrival times and the departure times, if you carefully notice, this one, and this one, all of the 3 were intersecting at some point. That is why you needed
Yeah.
3 platforms to accommodate these 3 trains. So if I can figure out
Okay.
the maximum number of intersections, I think that will be doable, right? So what I will do is
Yeah.
I'll pick up this like the extreme night solution. I'll pick up the train number 1 and I'll say, is this train like intersecting with anyone else? No, 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 no. So this train will require at max of 1 platform. Perfect.
Okay.
Let's take this one. Is this train intersecting with anyone else? Not with. If you,
No.
so this is definite. And this one is this one. So intersections that I did see was
Yeah.
3. That's it. Imagine a train is arriving at this time and it's leaving at this time. The dots are there.
Okay.
How can it intersect with other trains? One of the ways is the other train that it is intersecting with is has arrived previously and it will depart
Yeah.
after it. And it will depart
Yeah.
somewhere before departing later. Arriving before, departing middle. Arriving middle, departing later. Arriving middle and departing middle. So you have to consider 4 cases when you're considering the case of intersection, right? So
Yeah.
quite simple. That's what we will have to do. So what I can do is I can write down the function for the brute force. I'll be given the arrival time. I'll be given the departure time of n minus 1. Perfect. In terms of
Yeah.
you can arrival of is near about b of n. So can I say that the time complexity will be somewhere will obviously the interval last you to optimize. So we need to optimize n square. This is a clear indication that the algorithm that we're looking for will be somewhere around n log n or a b of n. Okay, so how do I optimize this? Now in the real world, what I'll do is I'll go outside the railway station and I'll start observing as the time passes by. So I see that the train number 1 arrives at 9 o'clock. This is the first time that you see something happening. So the train number 1 will arrive and it will take the platform number 1 or whatever platform number you can assign it. As the clock ticks by, what is the next time that you see? 9:20. At 9:20, again something is happening, and that is the train number 1 leaving. Train number 1 leaving. Okay, done and dusted. Platform is empty. What is the next time? 9:45 is when the train number 2 arrives. So I can say that at 9:20, 9:45, train number 2 arrives. What is the next time as the clock passes by? 9:55. The train number 3 arrives. As the clock passes by, 11 o'clock. The train number 4 arrives. As the clock passes by, what's the next? 11:30. 11:30, not 12. 11:30. Okay, that's train number 3. It goes off. As the clock passes by, 11:50. The train number 4 goes off. As the clock passes by, 1200. Train number 2 goes off. As the clock passes by, 1500, which is train number 5 arriving. As the clock passes by, 1800, which is train number 6 arriving. As the clock passes by,
Oh.
1900 is the train number 5 leaving. As
Okay. Okay. What if? Ah. Okay. 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 Hmm. Instead of doing that, we merge both and arrange in the form of a timer. Okay. Makes sense. Makes sense. Doing that, what if we? Hmm. That is a pair. And a pair. Five. Okay. I never thought to answer that. array dot comma, hmm, you know, 0. Just factor 1. Okay. 1 is equal to 1. Taylor is not equal to 1. For other, I see the answer. If I did not first, I did not second. Hmm. Okay. So now I'm going to trainerize. So we need that one. Obviously, so 900. So trainerize. Hmm. Give it 0 for now. So if trainerize, you know what count is equals to max of count comma local max. Okay. If I do second is equals to 1, that means train leaves. Yes, trainerize. And we haven't sorted it. So, I will put instead conclusion. Train leaves. What are the train leaves? Hmm. The train is leaving. Local max. Local. I don't know. Train line. Local max. That is. And that's just all that. Okay. First. Another pushback area of I. Another pushback area of I, comma 0. Oh yeah. Bring it up there. Hmm. Another pushback. Another pushback. That's all. Oh, okay. My bad. Well, that's all for today.